So there are a few announcements I have to make here before we continue with our class. The first announcement I will make is your final. Your final is no longer gonna be in campus anymore because of the spike of COVID-19. So I think you guys got an email from the president yesterday morning regarding with this issue. So I want to share the screen to you guys so you guys know. I sent you guys an email yesterday. So this is the email I sent to you guys regarding with your finals. So the campus actually will not have a lot of activities going on right after Thanksgiving because they are closing a lot of things. So there will be no more proctoring tests, no more testing in on campus for the finals. So all your classes that you have is no longer having a finals in campus. So it's all going to be online now. So your finals is going to be on Monday, December 14th. The time is at 1 to 2:30. It's 1.5 hours long. Here's a Zoom link. This is in D2L. So if also I sent you email yesterday. The chapter is 3, 4, 5, and 9, 1. And as usual, I will do 30 minutes before the finals. That means 12:30 to 1 o'clock. So if you want to do a review for your finals, log in at 12:30 on this link, and then the first 30 minutes you'll see a Zoom, and then at 1 o'clock you will get the finals, and you need a computer, you need a computer laptop with mic and webcam. So it's like what you guys did here, but you need to enable your webcam. So make sure you have your webcam ready so that so I can see you. I don't want to see your face. I want to see. So when you have a webcam, make sure you push move the webcam towards your paper. So I want to see your paper, you writing on it. And then you need internet connections, scientific calculators. So please make sure you go get a scientific calculator or borrow one. So you're not allowed to use any graphing calculators or cell phone calculators. Make sure you use plenty of papers and then writing tools like pencils and erasers and so on. How do I post the finals? Is looks something like this. You go to the chat room, and I will upload something out. Okay, I will upload like example here. You can see I am uploading something. I upload midterm key here. So so you can see do you see in your chat room that I upload a midterm key? So what you do here is you click on that imagine the midterm key is your final paper. So you click on it and then you take out a piece of paper and start writing write your name down. And then number 1, you do the question. Number 2, you do the question. Number 3. So make sure you have some room when you write on a piece of paper here. And then once you finish, can you guys see the midterm key? You guys able to view the midterm key? Using go to the chat room and click on the midterm key. Yep. So imagine that midterm key is your finals. Please don't write on the midterm key because there's no way you can write on it. And so what you need to do is you have to take out a piece of paper and you have to write on it. Okay, number 1, do your work. Number 2, do your work. And once you finish your task, how do you submit your task is you need to scan those papers. So once you finish writing all this down, so you will have to scan it. So I would recommend you, if you have a scanner at home, you can use the scanner. Otherwise, there are some apps, that are free apps in your cell phone that you can use to scan your task. So one of them is a cam scanner. So again, for you guys who do not know how to use a cam scanner or any apps before, I would recommend you to practice it because it's not that difficult. So and then you set it to my college email address. Okay, So it's going to be on Monday, December 14th. So there'll be all of you will be taking the test with me on this day from 1 till 2:30. So it's not going to break down into 3 days like Monday, Tuesday, Wednesday anymore. So there will be no on-campus testing for your finals. So your finals will be on the Zoom testing, will be look exactly like here, except you guys will have to put on the webcam. That means I want to see not your face, but your test. So you have to move the webcam down so I can write. I want to see what you're writing. And don't forget, class, only scientific calculators are allowed in your test. So like this one. So you are not allowed to use your cell phone as your test. So if I see you going use a cell phone, I will ask you what's going on. Okay, then I will kick you out from the class. If you have any questions, if there is a conflict between time, you might have another final during this time or something going on with this time on this day, you have to let me know as soon as possible. So all the teachers now should be planning for this final, since everyone not allowed to take finals in campus. So they're going to do all be Zoom testing. So for those students who have any questions, any other questions that you have, please email me as soon as possible, because I do not want you guys to email me on a Sunday or a Saturday on a day or 2 days before your test, your finals. Anyone have any questions with your finals here? Because it's a change. Anyone have any questions before we continue with 3.4? Now, so no questions, good. So I don't know you guys watched the video from 3.4 and 3.3. 3.3, I did it last week with another student and I sent it to you guys with the college email. So please check it. There's a link on that. I will post a link over here too. 3.4 that we did yesterday, this is the link. Sorry if there's two parts of it because I pressed the stop key. So that's the reason why that you have two parts. So I would recommend you to watch the 3.4, but we have not finished 3.4 yet. If you watch this, you only go through your online homework question 18. So we will continue with question 19 today. So those students who have, if you have any questions that is 1 till 18, please watch these videos, okay? Please watch this video. So we're gonna talk about question 19 and forward. And also 3.3, if you need help, please watch it carefully. And this last two sections, 3.3 and 3.4, is very heavy on synthetic division. So if you do not know synthetic division, you have to brush it up, okay? Or you have to watch the videos, okay? So we're gonna continue with 3.4 today. So there are three theorems that I already introduced to you guys on yesterday's video. So I just bring it up quickly here. What are the three videos here? Three theorems here. The first theorem is called the zeros theorem. So this zero theorem says that if you have your polynomial is xn, then you will have n zeros. Okay. So this is one of the theorems, says that if your polynomial has xn, n is your degree, means it's your highest power, then you will have n0. For example, is if you have like x4 here, this is the highest power you have, so you will have 4 zeros here. Okay, so if you have x3 here, the highest power is 3, so you will have 3 zeros. So that means that in this case, you will have 3 of these zeros. Okay, so that is one of the formulas for called a zero theorem. The second formula, second theorem we have is called a rational zero theorem. What is a rational zero theorem here is to figure out possible rational zero. Okay, so it's just to figure out the possible of it. So the answer in order for us to use a rational zero theorem is plus minus p over q, where p in this case is your factor of your constant, and q in this case is the factor of your leading coefficient. For example, if you have this function 4x cubed plus 5x squared plus 16 plus 20x 16x plus 20. So your p in this case is the factor of the last term 20. So this will be the factor of 20. And 20, the factor is 1, 2, 4, 5, 10, and 20. How do I get this factor? Factor means what times what is 20. So we know 1 times 20 is 20. 2 times 10 is 20. 4 times 5 is 20. So this is the factor for P. Okay. Q is the factor of the leading coefficient. Your leading coefficient in this case is 4, which is the highest power, the number in front of highest power. So 4, the factor for 4 in this case is 1, 2, and 4. Because 1 times 4 is 4. 2 times 2 is 4. So then what you need to do is, in order for us to list all these possible rational zeros, you have to divide them. So how do you divide this is, first you take all this factor of 20 divided by 1. So if you divide by 1, you will still get 1, 2, 4, 5, 10, and 20. The same thing, because everything divided by 1, you still get the same thing. And then now you will take everything you have on top divided by 2. So you will have 1/2. 2 over 2 is 1. We already got 1, so we do not need to repeat it. 4 over 2 is 2. We have 2 here. We do not need to repeat. 5 over 2. And then 10 over 2 is 5. We have 5. And 20 over 4 is 10 over 2 is 5. And 20 over 2 is 10. So we have all these numbers here. So we do not need to include it. Next, we will have to divide everything here by 4. So we will have 1/4. 2/4 is 1/2. We have that. 4 over 4 is 1. We have that already. Then we have 5 over 4. 10 over 4 is 5 over 2. So we have that already. And 20 over 4 is 5. So this is all your possible rational zeros. However, that you have to list this putting plus minus sign on it. So that means that every single possible rational zero here has to have a plus and minus. So I received some email from students that saying that how do you put plus minus signs in your online homework? I can tell you that if you put plus minus sign in your online homework, like if you do this as plus minus 1, plus minus 2, plus minus 4, and so on, the online homework will mark you wrong because your online homework does not like plus minus. So you actually have to individually list them out. So what do I mean here is you have to put 1 minus 1, 2 minus 2. So they don't do plus minus anymore. So in your online homework, you have to list like this: 1 and -1, 2 and -2, 4 and -4, and so on. But in my test, yes, in my test, you can just leave it like this. I understand what you're doing. But in your online homework, you have to list all like that. You guys have any questions with this? With the rational zero theorem, which is very important. Questions? All right, and the next one is the third theorem that we have is called the conjugate theorem. The conjugate theorem says that if you have a complex zeros, so complex means imaginary. So let's say a plus bi is a 0 in this case, then automatically a minus bi is also 0. Okay. For example, if a question says I give you a 0 of 4 plus 3i, then automatically 4 minus 3i is a 0. So usually if you look at your homework, they only give you one complex 0. They don't give you the other one. So you have to figure out that actually the other one is also a 0 in this case using this theorem. Okay. Another one is if I give you 6i, then negative 6i is also a 0 in this case. Now, this doesn't apply only for complex number. This is also apply for square root zeros. So if you have like 3 minus square root of 2 is a 0, then automatically 3 plus square root of 2 is also a 0. So this conjugate theorem also works for square root. You work for complex and you also work for square root. So a negative square root of 7 is a 0. Automatically root 7 is also a 0. Okay. So we can talk one of these questions in your homework here, which is question number 20. So 20 and 21 are the same. So we will use and then we'll come up with 19 here. So in order for us to do question number 20, it's given us that this is your polynomial function and it's given us 1, 0. So, the question here is asking us to figure out all the zeros. Now you have to watch carefully what kind of questions they want you to find. So if a question is asking us to find the rational zeros, rational zero means that zeros that is can put in fraction, like -1, 6, -5, 1/2, 3/4. All those numbers, like the one that I showed to you early on in here, these are what we call as rational zeros. This is called a possible. So these are what we call rational, means that they're all fractions. So if you have a square root as your 0, rational zeros does not take square root or imaginary. Okay. And then if a question is asking you for real solution or real zeros, then you will, then for real, your answer can be rational. This is for real. And it can be irrational. This is irrational, means square root or pi. So this is called irrational numbers. So that means for real, you cannot have I form. And then these questions that we have here on number 20, they want you to find all the zeros. So when you have all the zeros, the word all means that you have to be every zeros. That means it can be real, it can be all zero means it can be imaginary, it can be square root, it can be fraction, it can be anything. So make sure you guys read my, when you do my test, my final test, make sure you read the question really carefully, what kind of zeros they are asking for. So if the question is asking for all zeros, that means every zeros including the complex. So I got students think that complex doesn't, the I, oh, this is complex, so I don't need to find. No, not for this case. Okay. So the function is given us by this 4x cubed plus 5x squared plus 16x plus 20. And the 0 is given us by 2i. Because this is a power 3, so how many zeros you should have here, class? Using this zero theorem, power 3 means how many zeros you should have. Nang Pao, Justin, Mercedes. If you have power 3, how many zeros you should have? This is very easy. Yep, you should have 3 zeros. You should have 3 zeros here. But the question already provide you one of them. Now you can also tell me the other 0 by using this conjugate theorem, because this is a 2i. So can someone tell me what is the conjugate for 2i? Remember we talked about conjugate last time? If it's 6i, the conjugate will be negative 6i. So what is the conjugate for 2i? This is all important. It's in your finals. Yep, it will be negative 2i. So what we have in this case is you already have 2 zeros already. So you need to find the third zero. So how do you find this? You have to perform syntactic division. So what do you do here is you have to do the syntactic division with 4, 5, 16, and 20. And then you put the 2i inside here because this is the first zeros we have. And when you perform syntactic division, since they are zeros, zeros means that your remainder should be 0. So what do we do here is we'll drop the 4. So 2i times 4 is 8i. I'm going to move the 4 a little bit over here. So we have, so you always drop the 4 and then you have 8i. And then you always add these two together. So this is 5 plus 8i. Because they are not like term, you cannot be 13. So, and then what you need to do next is you have to multiply 2i with the 5 plus 8i. So how do we do that is you have to distribute. So when you distribute 2i to 5 plus 8i, it's like distributing x. 2i times 5 is 10i. And then 2i times 18 times 8i is 16i squared. And don't forget, I squared is -1. So this is actually is -16 plus 10i. So this -16 plus 10i will be in this, will be right here. And then next what we do is we add these two. So when you add these two, the 16 and the -16 will cancel. So you get 10i. So you need to multiply this 2i with 10i. So 2 times 10 is 20i squared, because I times I is I squared. And again, I squared is -1. So 20 times -1 is -20. Again, when you add this, you end up with a 0. So if you didn't get 0 on the last piece here, that means you did something wrong here. So you have to recheck your syntactic division. So this, we already did 2i. So now what we do here is the leftover that you get, we have to do -2i. So you have to do the conjugate of it. So again, the 4 is down, you have to make it down. So -2i times 4 is -8i. This is actually easier than the first round. This 8i will cancel. You're left with 5. And then 2i, -2i times 5 is -10i. And 10i plus -10i, you get 0. So again, you will get 0 here. And I want to point out to you guys that if you do, the reason why I said the second round is a bit easier is because your I here will all cancel out. So what you left in this quotient here, what we left here, they are no longer having I. So if you have I left in the next round, means that something is wrong. So I want to point out to you guys that when you perform syntactic division using your complex numbers, the first time you will get i's. The second time when you do it again, the i's is all cancel out. So your quotient in this case is 4x minus 5 equals to 0. And then if you solve for x, you will get the third 0. What is x in this case? Anyone? X in this case is what? Solve for x. You guys, this is easy. So that'll be 5/4. So your zeros, all zeros, they call it. So what is your answer for all zeros? Will be 2i, -2i, and 5/4. So this will be 2i, -2i. Make sure you put a comma to separate over your zeros, and 5/4. So this is your how do we do your answer in this case. Questions with this. Oh, what happens here? Why this is wrong? This is weird. This is very weird. Why this is wrong? This should be correct. Huh. Weird. Don't tell me that I have to put the symbol for I. Okay, I'm gonna check. It should not be the symbol for I. This is weird. Okay, this is the same thing. Let me check my work. Huh. Should be 5/4. 4, 5, 16, and 20. This is weird. Usually is correct. I don't know why this one is wrong. 10i minus 16, 10i negative 20. Yeah, this should be correct. Enter your answer code. Include the given 0 in your answer. Yep. This is very weird. Usually is correct. I don't know what happens here. Let's see if I can do it. That is so weird. Huh. I will look at this question again, but this should be your answer here. I don't know what happens here. This is my first time getting this wrong. Should be correct here. I don't know what happens. Then I put a space, then just space them. This one just space them. This is very weird. Again, if you have these kind of questions, you need to ask me. I will look for it and I'll check it out. So weird. Anyway, so this is how we do this. Now, in order for us to do question number 21, you need to know how to FOIL this kind of work. 3, let's see what we have. 3 plus 2i. Can you guys FOIL 3 plus 2i with 4 minus 7i? I want you guys to go ahead and FOIL this one out and see what you guys get. Go ahead and FOIL this one out. You guys know the FOIL, right? You need to know how to do question 21. Before you do question 21, you need to know how to do this first. Go ahead and FOIL this one out. And don't forget, you have to change all your I squared to become -1. And I'm looking at this question. This is the weirdest question I ever. Everything looks right. I don't know what happens. 8i 5 plus 8. Go ahead and FOIL that, and I'm doing my work. This is correct. I don't know what happens to that question. I will look at it. Go ahead and FOIL question 21. Now this. Anyone foiling? Anyone? Hello, Karishma? Yep.
I got 26 minus 13i.
Okay. 12 plus, yep, looks correct. Yep, that is correct. Okay. So make sure you know how to void this, and then change your I squared to -1. So if you doesn't know how to void this, then say goodbye to number 21. So question number 21, I will show it to you one more time because we're gonna do this quite a lot. Question number 21, because again, this is a power 3, and they give you 103 plus 2i. Can you tell me what is another 0 here using the conjugate theorem that we have here? Remember last time I give you 2i, you give me -2i. So what is the conjugate for this case? Three plus 2i, conjugate is 3 minus 2i, right? So in this case, again, you got power 3, you should have 3 zeros, and the question already provide you 2 zeros. I mean 1 0. You had to figure out the other 0 using the conjugate theorem. So now you doesn't know the third 0 like what we just did in question 20. It's kind of repeat, but this time you have to do the syntactic division on 3 plus 2i and then 3 minus 2i. So that's why you need to know how to do this for the gear. So as usual, how do we void here? You drop the 1. 3 plus 2i times 1 is 3 plus 2i. And then you add this together. So -9 plus 3 is a -6 plus 2i. And now you need to take this 3 plus 2i and multiply with -6 plus 2i. So that's why I told you guys to do this. So if you doesn't know how to do this, then you better pay attention here. So you have to take 3 plus 2i, and you have to multiply this with -6 plus 2i. So when you void this, you will get -18. This is a 2i here. Sorry, my handwriting. So 3 times 2i is a 6i. And then 2i times with -6 is -12i. And then 2i times with 2i, you will get +4i squared. And again, your I squared is a -1. So that will change him become -4. Because 4 times -1 is -4. So now when you combine the like terms here, this is -22 minus 6i. So this will be -22 minus 6i. And now you have to add these two together. So this 3i times minus 22, you will get 9 minus 6i. Okay, you will get 9 minus 6i. And now you have to void one more time with 3 plus 2i with 9 minus 6i. So you have to void another time with this. So same thing we just did over here. So 3 times 9 is 27. And then 3 times -6i is -89. And then 2i times 9i is +89. And then 2i times -6i will become -12i squared. Okay, so this will become -12i squared. And again, because I squared is a -1, So a -1 times with -12, you will get a +12. So what you get here is the 18i will cancel out. So what you get is 39. So this will came up to be 39. And you get a remainder of 0, which is what we're looking for. So whatever left over that you have to do syntactic again. So you have the 1, -6 plus 2i, and 9 minus 6i. The 0, you can skip it. And you're going to do syntactic division now with 3 minus 2i, your second 0. So like what we just did over here. So you drop the 1, and 3 minus 2i times 1, you will get 3 minus 2i. And what do I tell you here the second time you're doing here? All your I will what? Cancel out. So when you add this, you end up with a -3. And then 3 minus 2i times with -3, you will get -9 plus 6i. Because -3 times 3 is -9, -3 times -2i is 6i, and this will exactly cancel out, which you get a remainder of 0. So what we left here will be your answer. So that gives me x minus 3 equals to 0. So x in this case is 3. So your 0 in this case will be 3 plus 2i, 3 minus 2i, and 3. So the 3 at the end will be your answer in this case. I'm going to try this and see if I got this one right. So 3 plus 2i, 3 minus 2i, and 3. This one should be correct. Yep. So I don't know why this is wrong. Should be correct, 2i, and I don't know why. I will look at it again, but usually it's correct. Anyone have any questions with this? 20 and 21. Questions you have? You guys have any questions? All right. So now this is what we talk about. This first the 3 theorems that we have. Now we're gonna continue with the next 3 theorems. Do you guys need to take pictures of this? All right. Somewhere else. I just put this as. All right, so now we're talking about factors here. So the next thing we're going to talk about factors. This is the 4th theorem, factors. Now, when you ask for factor, factor is given us by x minus k. This is what is a factor form, where k in this case is your zeros. Okay. There are few types of factor form. One type is called a factor form that is irreducible over the rationals. What is a factor form irreducible over your rationals? It means that your factor cannot be factor with square roots or I. For example, I'll give an example. We will do this example so you see it. And then the next kind of factor is in the linear and quadratic. So when you have the word linear and quadratic type, means that your factor can be in linear. This is called linear. And it can be in quadratic type like this. So in other words, this is real numbers. That means that we don't do imaginary numbers here. And then when they ask you to do the complete factorization is any factorization in linear form where k in this case can be all zeros. That means it can be I, it can be square root, it can be like fraction, okay? Any number we want. So usually this is the one that we will do mostly, okay? The complete factorize. This is the one that we will concentrate more because mostly what we did. Now, remember last time when you guys did question 21, you find out that your 0 in this case is 3 plus 2i and 3 minus 2i and 3, right? If I want you to write this as a factor completely, it's very easy to write. Once you know your zeros, then it's very easy for you to write this in the factor form. Is you just take all this and you change your sign. So in order for us to write this in a factor completely form, it will be x, put an x first because every factor has an x first. Change all the sign here, so you become negative 3 minus 2i. And then the factor form for this one is x. Change all the sign inside here. This 3 is plus, become minus. This 2i is a negative, become plus. And then the factor form for 3 is x minus 3. So this is what we call as factor completely. So if a question wants you to put in the point in completely factor form, this is the meaning of it. And do you know what happens when you FOIL all this one out? When you FOIL all this one out, you will get back your original question, which will be x cubed minus 9x squared plus 31x plus 31 minus. So if you FOIL this factor form, you will end up with this original function. So that's the reason why we are concentrate more on the completely factor form, which is this one. And usually how you do this is we find the 0 first, and then after that you put an x in front, and then you change all your sign. This is what we call as complete factorize. So for example is, let's take a look at question number 19. So is x4 minus plus 20x5 x squared minus 125. So this question wants us to do as a factor this as a factor as an irreducible over the rationals, means this is just a normal factoring. So so you need to know how to factor this one. So x4 is x squared times x squared. 125, what is the factor for 125? So what times what is 125? Anyone?
-5 and 25.
-5 plus 25. Very good. Because -5 times 25 is a -125. When you add this, become positive 20. So this is what we cannot factor this anymore. The reason why is because 5 is not a perfect square. And we cannot factor this because of the plus. Usually when you factor, is a squared minus b squared, and the factor is a minus b and a plus b. This is the factor that we have learned in your algebra class. So this has to be perfect square, and this has to be a minus sign. So it doesn't work here because it is a plus sign. It doesn't work here because 5 is not a perfect square. So this, if we cannot factor anymore, this is what we call as the product, the factors over the irreducible over, it's the irreducible over the rationals. This is what we did in A. B, in a linear quadratic form, that means that it can be real numbers. So in order for us to factor this, we take whatever you have A and you can factor it. So actually 5, I know it's not a perfect square. We can factor this using square root. Because if I say 25, you know the perfect square is 5. But when you have 5, then what you do is the square root of 5 with plus and minus. So what happens to this for this case is this can be factored x minus square root of 5 and x plus square root of 5. This is what we did for this linear and quad in part B. Unfortunately, this one you cannot factor. The reason why this cannot be factored is because if you want to factor this factor is complex. How do I know this factor is complex? You can try to solve it. So when you solve x squared plus 25 equals to 0, you notice that you move the 25 become negative 25, right? And when you take the square root, this is going to be 5i. It's a complex. So that's the reason why that you cannot do complex in part B, because when I ask for real means that you cannot take any complex form. So that's the reason why that you cannot factor anymore on here. But for part C, when they ask you to factor completely, then yes, you can factor this. So you still have the x minus root 5 and x plus root 5 here. And this will become two factors. That factors belongs to your 5i. Remember when you take, and then you have a plus minus. So this will give me x plus 5i and x minus 5i. So usually a lot of students ask me, how do you know which one? And I told you that mostly what we usually what you do is you just solve it. Like here, you solve this is complex. When you solve here, x squared minus 5 equals to 0. X squared equals to 5. X is square root of 5 plus and minus. So you notice when you solve this one, this is actually is irrational. So that's the reason why that for part A, this is only for rational. Part B is for real numbers, so irrational is included. And then part C is for all. That means any, I don't care if it's irrational, rational, complex, anything, it goes in there. So once you get part C, once you got this factor, can you tell me what is your zeros here? So what you do for 0, you just need to set every single one of these as 0, which you already did it right here. So what will be your zeros in this case? This will give me what?
Negative 5 squared.
This is a positive root 5.
Oh yeah, negative.
And then this will give you what?
That'll be the negative square root 5.
Negative root 5. And this one?
Negative 5i.
And that one?
Positive 5i.
So this is usually, that's how I told you that in the test, mostly that we concentrate here is this, the complete factorization, because that is the one that I will ask you in the test. I don't care. I don't ask you for the part A and part B one, irreducible rationals and the linear quadrant and the quadratic factors. We don't do A and B a lot. So usually we only do C. And then once you know this complete factorization, then you can figure out your zeros easily. Questions? So these are the answer for A, B, and C for question number 19. Questions? Anyone? Okay, no questions. All right, then we have to go on to the next one. If you need to take a picture, go ahead and take a picture. Actually, question 19, I won't ask you in the test. I will ask you the next one in the test, which is the one that is more important. You guys take pictures yet? Or something else, screenshot, or you can, if you read it now, that's good. All right, so the next one we're gonna talk about is 22, 23, 24, 25. This is the one that I will say is that has that will come up in your finals here. So this question wants you to write this as a product of linear factors. What is a product of linear factors? It means that completely factor form, the one that we just did just now, part C. And then after that, you find the zeros. So so let's do question 22 first. 22 is too easy. No, not going to do 22. Let's do 23. x4 minus 81. These two are perfect square. So what is the factor for this case? Anyone know what's the factor for this case?
X minus 3.
X squared minus 9.
Sorry, yeah. X squared minus 9. X
X
squared.
squared plus
I-
9, right?
Okay. Yeah.
Because these are perfect square. Yep.
Mm-hmm.
Eric, you got it. Yep. And then we have to factor some more because these also are perfect square. So Eric, you just say, right, this is x minus 3 and
X plus 3.
x plus 3. This one you can also factor.
Yeah, that's going to be 3i.
You'll be complex. Yes. You'll be x minus 3i and x plus 3i. So this is how you write this in factor form, which is this one. So this is the one that you're going to type in here, exactly like this one, x minus 3i, x plus 3i, so on, so on, so on. And now the zeros is very easy to figure out. So the 0 for this will be 3. The 0 for this will be
-3.
-3. This is 3i, and then this is -3i. So these are if you know how to factor, the work is very easy. Same thing happens to question 22. Because 22 and 23, you can actually factor them. So if you know how to factor, that's the reason why that you need to know how to factor in this class before you take this class. Otherwise, you'll be struggling here. But however, when you do 24 and 25, this cannot be factored. Why I say it cannot be factored is because when you factor 3 terms, you split this into 2. And if you split this into 2, there is nothing in common factor in this case. This one you can factor x. You will get x minus 2. This one has nothing in common. So that means every time when you do a 4 terms factoring, if you factor something out, this also has to be matched. But unfortunately, you cannot factor here. So that's the reason why that question number 24 and number 25, you cannot do this using factoring stuff. No factoring. So how do you do 24 and 25? 25, we forget about x4. If you have x to the power 4, you cannot even do any factoring involved. So how do we do this is you have to find your zeros in this case. So how do you find your zeros? So actually you have to do the 0 first for this kind of questions. And then after that, you give it to me in the factor form. So in order for us to find the 0, you give me the possible 0. So the possible 0 in this case is P over Q. So P in this case is 26. So you give me all the factors for 26. So can someone tell me what times what is 26?
Plus or minus 1 and plus or minus 26.
Beside 1 and 26?
Plus or minus 26.
I know. I know 1 and 26. Yep. Beside that, plus minus always came in. So what else also goes into 26 beside 1 and 26?
Plus or minus 2. Plus or minus 2.
And
plus or minus 13.
13. Yep. So these are all the factor for 26. And the leading coefficient here is 1. So you have to do plus minus 1. So now when you divide this, so you will get the same possible 0, 1, 2, 13, and 26. So this is the possible 0. So now you're going to do trial and error. So you got 1 here, you got -2, you got 5, and you got 26. And you need to try to do one of these zeros, put in here, so you will get your remainder is 0. So this is where the difficult part in your task is. This is like a jigsaw puzzle or Sudoku. You have to try your own. So I'm going to try 1 first. So bring 1. 1 times 1 is 1. This is -1. 1 times -1 is -1, you get 4. So this one does not work because you will get 4, you won't get 0 in this case. So 1 does not work. So I'm going to try -1 because plus and minus means you can have 2 answers. So 1, -1 times 1 is -1, -2 plus -1 is -3. This will give me 3. 5 plus 3 is 8. -8. So again, -1 does not work. So because this doesn't give us 0. So our main goal here is to get 0. So that means we already use 1. So 1 does not work. No matter it's plus or minus, it doesn't work. Now we're going to try with 2. So 1, 2 times 1 is 2. This one becomes 0. 2 times 0 is 0. You get 5. 2 times 5 is 10. This one also doesn't work. So now I'm going to change with -2. So you will get -2 here. You get -4. -2 times -4, you get a +8. Oh, this one looks work. 5 plus 8 is 13. And what is -2 times 13? You will get -26. So -2 works in here. So that's the reason why I'm telling you here that this test, you're going to spend a bit more time doing syntactic division. Is because you have to figure out a 0 here. And once you figure out this 0, good job. Then what you do here is, this is your one of your answer. So now the leftover that you have here, you have to figure out your other zeros. So you will get x squared minus 4x plus 13 equals to 0. Now we cannot, if you can factor this, we factor this. But however, we cannot factor this is because the 13 is prime, that you cannot get 4. So you have to use quadratic formula here. So, so you got a -b, which is 4, plus minus b squared, which is 16, minus 4 times a, which is 1, we can ignore it, times 13 all over by 2a, which is 2. So in this case, you have to use your calculator. So 16 minus 4 times 13. This is -36. So this is 4 plus minus, this is -36. And the square root of -36 is 6i. And then you over 2. Now, when you over 2, you have to over 2 individually, like this. So your 0 in this case is 2 plus minus 3i. So in this case, we know your zeros, which will be -2. Don't forget you do -2. 2 plus 3i and 2 minus 3i. So this is your 0 in this case. So this is how you're going to do this 0 here. Now you want to put this in the factor form. So how do we put this in the factor form? Is you put x minus your zeros. Again, change all your sign. So if you got a -2, this is a +2. Change all your sign here, -2 minus 3i. And then change all your sign here. Don't forget your x, -2 plus 3i. So this is the factor form for this case. So for question 24 and 25, you actually have to find the 0 first, like what we did here. And then once you finish up finding the zeros, then you will give it to me in a factor form. So you're going to do the backwards in this case. So you don't do the factor first, you find the 0 first. Same thing happens to question 25. 24 is easier because it's a power 3. That means we have 3 zeros. 25, you got power 4. That means you have 4 zeros. So when you have 4 zeros, you have to syntactic division again one more time. This is for question 25. So when you have a power 4, when you syntactic division, you get a remainder of 0, you get a power 3. And when you do it one more time, you will get power 2. And when you get power 2, then you have to use the quadratic formula to figure out your other zeros. So in this case, in question 25, you will have 2 zeros like this, and then 2 other zeros that is using quadratic formula. I think that's imaginary. So you will have 4 factors in this case. You guys all right here so far with this kind of questions? Is that difficult? This is quite difficult, actually. I'm not kidding you. So this is how we do 23 to 25. And yes, it's in your test. Sometimes, I just want to point out to you in my test, because I do not want you guys to play around. Remember, I told you this one, I plug 1 and -1, 2 and -2. You play around with it because you are running out of time. So in the finals, I give you a graph. And the graph will look something like this, example. So this is the graph of this function, and it crossed at -2. So with this graph provided in your finals, you do not need to try 1 and -1 and 13 and 2 and so on, because for sure, -2 is a 0. So you just jump straight to -2. You guys with me here? So in your finals, I will give you a graph, look something like this, and a function like that. You do not need to find all these zeros, possible zeros. What you need to do is look at this. It cuts at the x-intercept -2, so you just syntactic division at -2. If you have a power 4, then I will give you 2 of them, like 1 and 2. So this is -2 and this is 3, example. So then you do -2 and then you do 3, because they already give you the 2 zeros. Then the other 2 is going to be imaginary, like the iPhone. Okay, so that's the reason why that this one is real, the other 2 is imaginary. You guys clear with me here in your finals? Because in your finals, I do not, because imagine you got a lot of possible zeros. You got like 20 of them. You don't have time to plug in each and every one of these to try 20 times. You go crazy. You already spend whole hour in here, you know. So I always provided a graph next to the equation. So what happened is that you do not need to do syntactic division so many times. You just look at the graph and say, you know what, -2 is a 0. So you just jump straight to -2. If there's 2 of them, you just do twice like this. You guys got it?
Yep.
So you do not need to perform so many synthetic division. Try and error. The last time we're going to talk about here is the last rules. The last theorem is called the Descartes' rule of sign. This Descartes' rule of sign is telling us how many possible negative zeros and how many possible positive zeros. So as you guys know that when you have a graph like this, so we know that this is a -0 and this is a +0. This theorem, the Descartes' rule of sign, telling us you will have 1 -0 and you got 1 +0. So what is the theorem says is the theorem says that if you have a function and if you count how many terms that it will change sign from positive to negative or negative to positive, and that will give you the number of positive real zeros. But you have to keep on subtracting it by 2 until it reach 1 or 0. I will teach you what it means. Okay, and this is for positive. For the negative zeros, you substitute your f of x to become negative. So that means you just change all your x to become -x, and figure out how many, if you change the sign from positive to negative or negative to positive, then this will figure out the number of negative real zeros. And then you have to subtract 2 until you reach 1 or 0. So I will tell you, so this is for question number 26, 27. So this is using Descartes' rule of sign. So I'm going to do 26 first, and then you try to do 27. So g of x in this case is given us by 2x cubed minus 3x squared minus 7. So the question is asking for how many positive and how many negative do we have. So what you do is you look at your terms and see if your sign changed or not. So when you go from here to here, this is positive term and this is negative term. So your sign change. From here to here is a negative to negative. The sign did not change. So since you only change one sign, so you will get one positive real zero. So this is how we figure out using this theorem. So you just look at your sign, your term, and see how many times it changed. Next, I will replace all my g of my x to become negative x. So all my x here become negative. So this, when you cube a negative, you become negative. So you get a negative 2x cubed. When you square a negative, it will be positive. But positive times negative, you get a negative 3x cubed. And then you got minus 7. So now you look at how many signs does it change. From here to here is negative to negative. It doesn't change any sign. From here to here is also negative to negative. It doesn't change any sign. So this telling us that this one have zero negative real zeros. So so this question will have one positive with no negative. So this is the answer for this case. What does this mean here? It means that when you draw the graph for this function, your zero will only cross at the positive side. So when you do the possible zeros, when you do the plus minus 1, plus minus 2, and then when you try to do syntactic, with this going on, you did not need to worry about doing all the negative sign. You just need to worry about doing all the positive sign. It's because this theorem tells us there is no negative zero at all. So this theorem actually helps you to eliminate the possible zeros. Remember last time I gave you you got plus and minus, then you got a lot. So if you know about this theorem, you can eliminate those one, the negative one or the positive one. So that's what happens to this this Descartes rule of sign. So you have to figure out using this. And then the last thing we're going to talk about here is using the upper and lower bound. So what is upper and lower bound theorem? So the upper and lower bound theorem is telling us that if you divide this, okay, for the upper case, if you divide this with a syntactic division, and if all this number turns out to be positive, then this is your upper bound. Upper bound means that if you have a 0, this is your upper bound. Means that there is no zeros after that. And for the lower case, for the lower bound, you do the same thing. You do your syntactic, but your sign is changing down here, plus, minus, plus, minus, plus, minus. Then you figure out this is your lower bound, means nothing can be changed here. So for example, that last time when you do 1, 2, 3, 6, and let's say 12, let's say my upper bound in this case is 2, and my lower bound is a negative 1. So that a negative 3, let's say. So what happened is you do not need to do syntactic division 6 and 12 because your upper case in this case will be 2 and your lower case is negative 3. That means your 0 can only take from negative 3 to 2. So that means if you use your P over Q, if you get 6 and 12, you do not need to worry about it. And then the good news is if you got something like what we have here, you cannot have a negative. So when you do your syntactic, you just need to concentrate on all positive. So this is what we call as the upper and lower bound. So what is going on with these two theorems that the last two theorems that we're talking about here is to eliminate all your possible zeros. So you do not need to use a syntactic division forever. You know, as I told you, you have to try it over and over again. So with these two theorems, you eliminate the possibilities on this case. So so that's the reason why that these two theorems will not be in your test, but it will help you to figure it out. So that's it for today's class. Anyone have any questions for me? I'm going to stop sharing here. Does anyone have any questions for me in this case?
I was kind of struggling with number 31.
31?
Yeah. Curious if you could help me out with that one.
Sure.
Thank you.
Yep. If you guys want to stay, if you want to stay, I will definitely do that. So 31.
Yeah. On 3.4.
Yep, this is 3.4.
Okay.
No, this one, right? Is it open box?
Yeah.
So open box, we have 15 by 9. So you have a rectangle that is 15 by 9.
Mm-hmm.
And you cut X out.
All right.
And then you fold this, it'll become a box, an open box. Okay. So when you cut X out, what is the distance from here to here?
Here, are you? I don't think you're sharing your screen.
Oh, sorry. Oh, sorry about that. Yep. Thank you for telling me because
Yeah.
There you go. Oops. Sorry about that. So so you got a rectangle, 15 by 9.
Yep.
And you cut X out. So what is the distance from here to here?
15.
No, here to here is 15.
Yeah.
But I'm talking about from this side to this side.
12.
From here to here is 15. How about, so you take X out here, you take X out here. So what's the distance from here to here? Is 15 minus 2X.
Okay.
And that is this one.
All right.
How about from here to here?
9 minus X.
2X. Very
2X.
good. Close. 2X. Boha. Because again, you take X out and you also take X out here, right?
Yeah, okay.
So this will be 9 minus 2X from here to here. And then what about this one? What is your height? Your height is the same thing as your box, the square you take, the X. So question A is asking us to find the volume of this box. So volume is length times width times height, right?
Yeah.
So length is 9 minus 2X. Width is 15 minus 2X, but the other way around doesn't matter. And height in this case is X.
So then you just FOIL it.
You just FOIL this. So FOIL this one first. Yeah, you need to FOIL it up. Why you the one? What the heck with this one? That X represents, sorry about that. I'm reading this question, so weird. That X represent, go ahead and FOIL this one out, yep. And then once you finish foiling, you multiply x inside, distribute x inside. Next. I don't think so. You need to say draw. So this is a picture that this is actually part A. The picture, I know it's not that nice, but this is what the picture looks like. This is actually, we're doing part B now. So I think you skip part A. You do not need to draw it. How can you draw? Oh,
Yeah.
You don't draw it. You just give me the sides. So the side in this case will be 9 minus 2x. Sorry. That is this one, right?
Yeah.
And then the other one is what? 15 minus 2x. And then x. So this is they don't call you to draw it. They want you to give me the side of each square, the dimension of the box. So the dimension is 9 minus 2x, 15 minus 2x, and x. You got it? So this is the dimension they want. The length, the width, and the height. And now for part B, you have to find the volume, which you have to FOIL up. What you get when you FOIL this one up?
4x cubed.
4x cubed.
Yeah, minus 48x squared. Plus 135x.
Plus 135x.
35.
Yep. So this is going to be in part B.
Okay.
Now you have to figure out still in part B, you have to find the domain. In order for you to find the domain, you just need to pick one of the dimension here and you solve for x, and we pick the smallest one. So we will pick him. So in a domain here, you pick the smallest one. So it's 9 minus 2x equals to 0. So x in this case is 9/2. So your domain in this case will be from 0 to 9/2. So as you know that domain is what's the x value? So that means how big the box, the little square box, you have to tear it out. You cannot be exactly 0, because if you have 0 means you're not tearing any square out, means you cannot form a box. The reason why we pick the smallest one is because if you pick the biggest one, you tear a lot of, you tear more than 9. So that means you won't able to, you've tear everything out. So there's no leftovers. So that's the reason why the domain in this case, you take the smaller one and then you equals to 0. And then you solve for it. And then you get 0 and 9/2. You get it?
Yeah.
Next, sketch the graph. Sketching this graph is not too difficult because you already know the 0 here. So the 0 in this case is 4.5, right? 9/2 is 4.5, right?
Yeah.
And what is 15 minus 2x equals to 0? This is 7.5, right?
Yeah.
So which one here shows you that have an x-intercept at 4.5 and 7.5? It's going to be the first one.
Yeah.
This is 4.5. This is 7.5, right?
Yep.
So we can tell the graph very easily. Approximately the dimension box that yield the maximum volume. So what you do here is you just look at this parabola, and this vertex is called the maximum. Okay, and that will be what, around 10, right?
Yep.
So this is around 10. Let's say I think 6 is the highest. 6 is the you can use your remember you learned this in 3.1. Since you got this, do you know how to find your vertex? Using negative b/2a.
Yeah.
Right? This is for the maximum volume here. So and then you put the f of that one, right? So what is B? This is your B, this is your A, right?
Yep.
So it will be 48 over by what?
2 minus 4.
2 times 4, right?
Yeah, so 8.
8, so it's 6, right?
Okay.
And then you plug 6 into your X, right?
Yep.
So you will get 4 times 6 cubed minus 48 6 squared plus 135 6 times 6. So whatever answer you, I think it's around 10. I think that's your answer. Let me see. 4 times 6 cubed minus 48 times 6 squared and then plus 135 times 6. I'm going to use my calculator because this one looks weird. I hate this. Yep, I think you guys know how to use your calculator to do this one, right? 4 6 to the power of 3 minus 48 times 6 squared plus 135 times 6. Oh, it's negative 54. Oh, that's weird. Remove the x. So just do x squared, x1. Just remove your x, so it becomes square and 1 because it's a parabola. So let's do 4 times 6 squared minus 48 times 6 plus 135.
Okay.
Sorry about that. Remove the square because it's a parabola. So see what you guys got. 666.
6.
That's wrong. Nope. I will just ignore this. I think it's around 10. You know, I will put, because by looking at the graph, I will give you the answer. I think it's 9 point something. I know it's 9 point something.
I got -9.
This is 9 point something actually. If you look at this graph, it's 9 point something. But I will give you this answer so you can skip it, so you don't have to worry about that. But the D is the one that I want you to show to you how to do part D, because I'm really running out of time here.
Yeah.
So, part D is the one that. So next they want you to find the volume of value of X, where the volume is 56. So what do you do in this case is you take this equation that you have and you put 56 here. That's your volume.
So it's equal to 56 instead of 0.
Yep, because that's what but you have to make it equal to 0. So you have to move the 56 over.
Yep.
So you will get 4x cubed minus 48x squared plus 135x minus 56 equals to 0.
Mm-hmm.
Now this you cannot factor. So and I don't want you to use the P over Q because it's going to be it's going to take you forever to figure out using syntactic, you know what I mean?
Mm-hmm.
And then you figure out, oh, it's 5, it's 3, and you can do all these things. So I would recommend,
Use a graph, right?
Huh?
You can use a graph for this on the 0.
Yep. So I will give you a graph for this.
Okay.
So go to Desmos. That's the easiest way. And then you just type in this function in there, 4x cubed minus 48x squared. Do you know about this Desmo? They actually give you graph. They draw you graph nicely for you. Minus 48x squared What's the next one? Plus 135x minus 56, right? So this is the graph. And we find out that 8 is a nice 0. Do you see that? You also got this, and do you see all the zeros?
Yeah.
So the zeros in this case will be 8. You tell you 3.5 and what? 0.5. You see that?
Mhm.
So so your 0 in this case will be 0.5, 3.5, and 8. Otherwise, you do synthetic division here by 8. And then you will figure out that then after you factor whatever you have here, and you will still get 8, 1/2, and 7/2. 3.5 is 7/2. So you will get these zeros. Okay. So the zeros for this case, it will be where was my, there you go. It will be 8, 0.5, and 3.5. Oh, sorry, this one is this one. Yeah. Over here. This is the one that I need to show you how to do it. And then, but which one of this value is physical impossible? So because your domain that you have goes from 0 to 4.5. Remember you did the domain here?
Mhm.
So you only go from 0 to 4.5. So which one of these zeros cannot take?
Can't use 0, right?
Out of these 3 numbers?
Oh, 8.
8, yep. So 8 is the one that is impossible to have because your domain, and the reason why is because the value is not in the domain. Because your domain is already stated from 0 to 4.5, right?
Hmm.
So 0.5 is good, 3.5 is good, 8 is out because it's out of the domain. So the value is not in the domain. So that's what your answer is. I will tell you this answer here. Should be, I will give you the answer later on. You just skip this one. Skip it. I think your answer is 9 point something. I'll give your answer to you. So skip it. Don't worry about this one. You okay there?
Yes.
Yep. Skip that one, and then the rest I'll give you the answer for this. I think it's 9 point something. Yeah. Oh, it's this one. It's the wrong graph. Should be this graph. Oh yeah. The graph is this. I'm so sorry. Is this graph? The reason why the graph is this is because you cannot, your domain. I forget my domain here. So the graph is this graph. Is the reason why it's grid graph is because it's go from 0 to 4.5. You cannot have a, so 0 to 4.5. This is a domain. So you cannot take this these 3 graphs because this one domain is 0 to 9. This graph is, so the graph in this case is this one. It goes from 0 to 4.5.
Okay.
Yep, sorry about that. So the graph is this, where you look at your domain. This one, I give you the answer. The maximum, I think the maximum volume is what we calculated last time when you put this cube in there. This, I think the maximum volume is this one when you put a cube inside here.
I turned these in and I did A. For A, I put 9 minus 2x and then 15 minus 2x.
You put comma to separate them?
I didn't separate them, no.
You had to put comma to separate them.
Okay.
So you say use comma to separate your answers.
All right, cool.
So yeah, this is the one that I will want you to skip. I will tell you what is the answer in this case, okay?
Mhm.
I think it's around 100 and some, 110. Let me see, 110. So this is, I think it's 110. By looking at the graph. Nope, I'll give you the answer, don't worry about that. It's right over here. This is the maximum in this case.
All right.
Okay, I'll give you the answer. Don't worry about that. I'll give you the answer in this case.
Thanks, David.
Yep, sorry about that.
Oh, you're good.
Yep. I have to go here. I have another Zoom lesson here. So I'll give you, I'll submit, I'll tell you the answer. So yep, I need to, yeah, I think it's 100 something. Yeah. All right.
Okay.
So if you have any questions, email me back.
All right. Thank you.
All right. See you guys.